sklearnmetricsclustercontingencymatrix. Contingency matrix. Description. The contingency matrix function in scikit-learn's cluster module is a tool used to evaluate the performance of clustering algorithms by comparing the predicted cluster labels with the true labels. Inputs. Labels true A1D array representing the true labels of each data point. Label spread A1D array representing the predicted cluster labels assigned by the clustering algorithm. Outputs. Contingency A2D array matrix where the ij entry represents the number of samples that are in cluster I according to the true labels and cluster j according to the predicted labels. Steps. The function first creates a contingency matrix with dimensions equal to the number of unique labels in both the true and predicted labels. For each data point, the function identifies its true label and its predicted label. It then increments the corresponding cell in the contingency matrix. Metrics. The contingency matrix itself is a useful metric, providing a visual representation of the clustering performance. Metrics like the V-measure, adjusted rand index RE, and homogeneity, completeness, and F1 scores can be calculated from the contingency matrix to quantify the agreement between the true and predicted labels. Visualization plots. Heat maps. The contingency matrix can be visualized as a heat map, where the intensity of color in each cell represents the number of samples belonging to that combination of true and predicted clusters. Fine-tune parameters. None. Uncertainty methods. None. Challenges and fixes. Challenge 1. The interpretation of the contingency matrix can be challenging for large numbers of clusters. Sample use case that resulted in challenge 1: clustering a dataset with 50 clusters, resulting in a 50 by 50 contingency matrix, making it difficult to visually interpret. Fixes to challenge 1: consider visualizing a subset of the most relevant clusters or using alternative visualization techniques like dendrograms to understand the relationship between clusters. Challenge 2: the contingency matrix alone does not directly provide insights into the quality of the clusters, e.g., compactness, separation. Sample use case that resulted in challenge 2: a perfect contingency matrix, where all samples are correctly assigned to their respective clusters, could still indicate poorly defined clusters if the overall clustering structure is poor. Fixes to challenge 2: complement the contingency matrix with other metrics like silhouette scores, Kalinski-Haraba's index, or Davies-Bolden index to assess the quality of the clusters.